This video is going to show you how Faraday's law applies to a graph. So a quick little review. Magnetic flux is BA cosine theta, where B is the magnetic field, A is the area. Cosine theta is the acute angle between the area vector and the B field's direction. So remember, we have a hoop, conducting hoop of some kind, and it's got an area which is coded, you can see it in red, or sorry, in blue. And the area vector is perpendicular to the actual surface itself, so the area vector will be pointing up, not left or right. And then it's going to have a magnetic field going through it. In this case, the magnetic field's going straight up. Then I have this induced EMF, which is a voltage, and that's equal to the negative of the number of coils times the change in flux over time. Recall that Ohm's law is equal to V equals IR, and the induced voltage, or the induced EMF, is the V in V equals IR. What that means is because the coil's resistance isn't going to change, the current is proportional to the induced voltage, which means that current is proportional to the number of turns times the change in flux over time. So if I think of this in terms of a graph, I can have the flux on the vertical axis measured in Webers, and the time along the bottom, the horizontal axis, measured in seconds. And so I get some kind of linear graph. Now let's look at this graph a little bit closer. If I look at it closer, I can do what I normally do in math class and see what the slope is going to give me. So I can look at the run, which is the change in time, and the rise for those 2 points on my line. And that rise over run is the slope over here in our equation. So the induced EMF is actually going to be proportional to the slope on the graph. So the induced EMF is equal to the negative n times the slope on a graph of flux over time. And also, because of what we did earlier with Ohm's law, it also means that the current through my conducting hoop is proportional, not equal to, but proportional to the number of negative number of the number of turns times the slope. Now the next thing that we can do is we can apply all these tidbits, and that's what's done in those other example problems in the other videos.